I'm recording this trying to help people understand p-values a little bit better. So this is the problem from back in chapter 21, and they're telling us that 28% of the motorcycles on the road or registered are Harley-Davidsons. And we want to come up with a sampling distribution for this. Well, the center of the sampling distribution is the 28%. And we know that central limit theorem tells us that repeated samples will, especially of size 600, will form a normal distribution. If we do a whole bunch of samples of size 600 and figure out the percentage of motorcycles that are Harley-Davidsons, all those p-hats, or those percentages, are going to form a normal distribution around 0.28. So this problem's asking us to set up a 68, 95, 97 rule, so we'll do that. So to calculate the standard deviation for the sampling distribution, I used that measure the 28% as my p, and calculated that. Sample size is 600, so that's what I said my standard deviation was, and now we want to set up that normal curve so we can understand what's going on with it a little better. So make a little sketch, put 0.28 in the middle, and then I'm going to my normal distribution set up, use it for the 68, 95, 99.7 rule, and that's what it looks like. And so I know that 68% of the distribution falls in here, and 95% falls in between those blue lines, and 99.7, practically all of it, falls in that range. Okay, and that's the sampling distribution for this. And now what we're going to do to start thinking about p-values is start seeing where does it fall in relation to what we know where most of the samples are going to be. So I just went online and out at Forbes.com and found this result from last year, and it showed us that there were 3,126 Harleys stolen out of. This was 2011. So this is the right year. So there's that many Harleys. So if we consider this a sample, a random sample, that's questionable, but we'll go with it because we're trying to figure out about p-values. So if I'm doing this calculation right, there were 3,120 Harleys and stolen out of 4667, so that would be our p-hat. And calculating p-hat, I see that's a little over 6.7, 6.69%. So then the question arises, are Harleys being stolen at a lower rate, at least for that year, than they are in the registrations? So I'm going to set up a significance test to test this out. It certainly looks it. Is that just due to chance, though? So our hypotheses, our null hypothesis is the proportion of motorcycles that are being stolen is equal, 28% of the motorcycles stolen are Harleys. And I don't know, I'm looking at that test result. I want to know if it's actually less than 0.28%. Okay, so now some things I know is that my p-hat value is that 0.06, what was it, 0.0669. I know my null hypothesis value, my population proportion, I'm thinking is 0.28. I know that my sample size was 46,667, pretty large sample. Now I got to come up with a new standard deviation for this because this is a different, I'm not doing a sample of 600 anymore. I'm doing a sample of 46,000, considering that whole year a sample. So to get the standard deviation for this, I'm going to have to do square root of 0.28 times 1 minus 0.28 over the 46,667. I'll calculate that and come back. So if I did punch these numbers into the calculator right, I got a pretty small standard deviation. Of course, that's a pretty large sample size, so I'm rounding. So now I'm going to calculate a test statistic, or maybe let's do a new normal curve and just to kind of get an idea where this is going to fall. So this is what the sampling distribution for that looks like. Now, one thing I'm seeing here is that 6.6% is way off the scale. It's way down here. So there's two things happening. Either that wasn't a random sample and we really can't use this technique for that, or we can say that's a really rare, this is way outside the range of possible values if 0.28 is the true percentage of Harley-Davidson, true percentage of motorcycles that are stolen are Harley-Davidson. So our p-value is going to be very small, and we can go through and calculate that right now as it is. Just calculated the z-score for that 2011 year, and I'm getting a z-score of negative 101.5. Well, that is way off the table. Table A only goes to like negative 3.5, I believe. So, it's way off the table. So the likelihood of this happening by chance is zero. There's no way that 28% of the motorcycles being stolen are Harleys. So based on this result, we can reject HO. It's going to be such a small p-value, and we knew that when we looked at that the chart I set up before. So we can reject HO, and it looks like, yeah, the rate of Harleys being stolen is less than 28%. Okay, so that's one way. That's one way to look at this without what to think about the p-values. That p-value is the chance of being wrong if you reject HO, and we have a chance of being wrong of almost zero. So I hope that helps you out.